And lesson 35 is going to be dealing with the standard form of a linear equation and learning to find the x and y-intercepts of that linear equation algebraically, and then using those x and y-intercepts to graph the linear equation. All right. So just a little bit different method of graphing. I think y'all may have done this last year. I'm not sure how much time you spent on this. Most of your time last year with linear equations was spent with y equals mx plus b, and that's a great place to spend it. All right. We're going to be looking at today is the standard form of a linear equation and how to use a standard form of the equation to graph the equation. All right. A little bit different technique, right? How have we graphed so far with y equals mx plus b?
So, we find the slope in the y-intercept?
Well, we haven't done that yet this year. That's what you did a lot last year. How have we used this year to graph the equation? Right? Make a table of values and plug in numbers and find. That's a great technique to use to graph linear equations, right? If a linear equation is in slope-intercept form, we can use the slope and the y-intercept. We haven't done that yet. But we could also make a table of values to find ordered pairs that are solutions to the equation. Right? Now, I do want you to write this because this is an important reminder. An ordered pair or a set of ordered pairs that satisfy an equation is called the solution of that equation in two variables. All right? That's an important concept. If you have an equation that has two variables, like something like y equals 2/3 x minus 4. That's an equation that has two variables. It takes an ordered pair to satisfy it, right? You have to have an x and a y to get a true statement. And we've found those solutions by making a table of ordered pairs. Okay, so what we're going to be doing today is a little bit different from that. So, y'all finish writing this down?
No.
The solution of a linear equation or any equation that has two variables is going to be an ordered pair. You don't know what this is, but y equals the natural log of x.
Whoa.
Yeah, there's a button on your calculator that has ln. You don't know what it is, and you don't need to look at it, but you could take x and y values, and you could put 6, 7, 8, 9, 10 in there. And you could come up with some y values, and you could take those ordered pairs, and you can use it to sketch a graph of that function. All right? You don't even know what it is, and you can follow this table of ordered pairs directive and sketch a graph of the equation. So that's a great way to do numerical analysis on a function. Okay? Now, there's another way. If an equation is in standard form, we can graph the linear equation a different way. Now here's what we've got to define, right? What is standard form of a linear equation? Don't write it down yet. Does anybody know? The next screen is going to tell us, but what is the standard form of a linear equation?
Like beginning? Like the first? No, I'm trying to think. Is this
the most simplest form?
No, it's not simplest form.
Does this have anything to do like when back in elementary when you like the expanded form?
No. No. Standard form is just the name, like slope-intercept form is the name of a form of a line.
Okay.
Standard form is another name of a form of a line. And then we've got one more that we'll learn, pick up in Unit 5, I think, maybe Unit 6. That is the point-slope form. Okay, so we'll do all of your high school and all of the ACT deals with three forms of linear equations. Slope-intercept, standard form, and point-slope form. We've looked at slope-intercept a lot last year and some this year. Standard form may be new to you. The standard form of a linear equation is this. Ax plus by equals c. All right. Now, we have to give some meaning to what a, b, and c are, or we have to put some conditions on these three parameters. In this equation, x and y are variables. Right, we know that. That's our two variables. A linear equation with how many variables? Two variables. And A, B, and C are called parameters. These are the parameters of the equation. X and Y are the variables. A, B, and C are the parameters.
Do A, B, and C have to be capitalized?
Yes.
Okay.
In slope-intercept form, X and Y are the variables. The two parameters are slope and y-intercept, right? M and B are the parameters. The slope and the y-intercept are the parameters. Okay. Now there's conditions on A, B, and C. Now if you're one that likes to look at the textbook and see how the textbook defines things, the textbook leaves out a lot of what I'm about to tell you, and the textbook is wrong for doing it. So the textbook is, even some of the answers from these questions is incorrect. So we got to fix it. We're going to use these three parameters, which is standard mathematical. I've never seen a textbook that messes this up. Saxon textbook does mess this up in lesson 35. Here's the three conditions on the parameter. All right, the parameters. A and B can't both be 0. All right, that makes sense. If A and B were both 0, then we don't have any variables in the equation. And to have an equation, a relation, or something that's going to generate ordered pairs, we need to have at least one variable. A and B can't both be 0. If they were, then we'd have 0 equals something. That's what do you do with that? Okay, and that's kind of a condition on A and B. The next one, A must be positive. All right, so here's an example of something that would violate that. You could have negative 2x plus 3y equals 7. That's not considered standard form because the A value is negative. How do you fix that? You multiply through the entire equation by a -1, which is equivalent to just going through the equation and changing all of the signs. This is the standard form of that. Okay? Now, so A has to be positive. And the third condition is the one that's a little bit more difficult to understand. We'll take it apart piece by piece. A, B, and C have to be relatively prime integers. All right, well, we got to define that, right? We got to define what relatively prime means. We know what integers means, right? What does that mean? Let's define it by what it can't be if it's an integer. Can't be no fractions, no decimals, right? No fractions, no decimals is what that means. All right, so you can't have. We'll talk about how you'd fix that in just a second in context. Saxon doesn't. This textbook doesn't make this condition at all, or this one. That's bad. Okay. The reason that these rules exist is so that a student in China and a student in the United States taking the ACT can come up to a standardized answer. Everybody's answer should look the same if everybody follows the same rules, right? But you can't have negative 2x plus 3y equals 7 as standard form and 2x minus 3y equals negative 7. Both of them can't be standard form. So that's why this rule means that this one is the standard form answer. Okay? So we use rules so that everybody's answers can be standardized. So they have to be relatively prime integers. We know what integers are. It means not fractions, not decimals. What does relatively prime mean?
I don't know.
What does relative mean? What's the root of that word?
Relative.
What's the root of relative? Relate. How they relate to each other. They have to be relatively prime. Means that they can't all three have a common factor. So let me give you an example of an equation that would not be relatively prime. 2x plus 6y equals 30. They're all divisible by 2, so they're not relatively prime to each other. They all have a factor of 2. How would we fix that? We would fix it by dividing everything by 2. We're allowed to do that, right? It's an equation. So it would give us x plus 3y equals 15.
But then you got 3 and 15.
Yeah, but A, B, and C.
Oh, they have to
all 3
can't be the same.
Can't have the same factor, right?
So if they are the top thing, then they're not relatively prime?
Yes, right. This is the standard form of this equation. All right? Standard form, you can't have all 3, A, B, and C, can't all have a common factor. They can't all be even. They can't all be divisible by 3. They can't all be divisible by 5. All right? So they have to be relatively prime. And what relatively prime means is that they can't all 3 be divisible by the same number. Okay? All right, now, under these conditions, everybody everywhere will always come up with the same answer if it's asked for in standard form. And it is asked for a lot on the ACT. You'll hear, what is the standard form equation of this line? Okay? Standard form. All right. Now let's have a look at maybe some examples here that we'll look at. So standard form. Let's look a little bit more. A couple more definitions. Right. Yes, this is huge. Definition. The x-intercept. Because remember what we're trying to do today is use the x and y-intercepts to graph equations of lines that are in standard form. So what we've done up to this point is define what standard form is. Now we need to define what x and y-intercepts are, and then we'll put it to use. So this definition is important. The next one's even more important. What do all points on the x-axis have in common?
They're all on the x-axis.
Every point on the x-axis has what in common?
0.
What do you mean by 0?
It's on the 0 on the y-axis.
It has a y value of 0, right? So the x-intercept graphically is defined to be the point where the line crosses the x-axis. Algebraically, the x-intercept occurs where y is equal to 0. So if we want to know what the x-intercept is, what do? If we want to find the x-intercept, we plug 0 in for y. Solve for x. Right? And conversely, the y-intercept, by definition, is the point where the line crosses the y-axis. That's the graphical definition of the y-intercept. The algebraic definition of the y-intercept is the point where what happens? What does every point on the y-axis have in common? Right? Every point on the y-axis has an x value that's equal to 0. So if we want to find the x-axis or the x-intercept, then we want to substitute 0 for, I said x-intercept, I meant y-intercept. If we want to find the y-intercept, we need to plug it in. Now, this second definition in both instances is the one that I am concerned with, because I want you to know what it is algebraically so you can do the algebra to find it. We're not going to find the y-intercept graphically. We're just not going to do that. We're going to find it algebraically. Unless we're given a graph and asked to identify the y-intercept, but everybody can do that. That's pretty easy. All right. Algebraically is what I'm interested in. So if I ask you what the x-intercept is, I want you to tell me it's where y equals 0. That's the definition I want. What is the y-intercept? It's where x equals 0. All right. Now, if we know the x-intercept and we know the y-intercept, then that's 2 points, right? If we have 2 points, then we can draw the line. Right? Can't we know what the line looks like if we have 2 points? So let's find the x and y intercepts for this graph. First of all, is this in standard form?
Yes.
3x plus 4y equals 24. And while 3 and 24 have a common factor, 4 and 24 have a common factor, they don't all 3 have a common factor. No fractions, a is positive, it meets the condition. So there's a lot of things you have to account for standard form. All right, what is the x-intercept? The x-intercept occurs where y is equal to 0. So we know that the y-coordinate is 0. It's really pretty easy, right? If y is 0, x is 8.
Oh.
It's really easy, yeah?
We've done
I was making that way too complicated. Yeah.
And the y-intercept is where x is 0.
It's just 6.
So if we 0 out the x, what do we?
6.
Y is 6.
So we can graph a whole line like that.
Yes, sir.
8.
Yes, sir. And if it's in standard form, this is the easiest way to graph a line from standard form. Now we're going to use standard form for a lot of things. We're going to use the slope is easy to see. The slope of this line is -3/4. I know that because I know how to find the slope from standard form. The y-intercept is 6. So I can see all of that from this, we can do this. So the slope-intercept form is y equals -3/4 x plus 6. But that's going to be something that we'll attach later. All right? We already know how to solve this for y to get it to this slope-intercept form. Subtract 3x and divide everything by 4. Now, this doesn't tell you to, but we could use these 2 points to do what? To graph the line. All right? Have a look at the next example here. This says graph using the x and y intercepts. Now, this doesn't say anything about determining if it's in standard form, but is this in standard form?
Yes.
It is. A is positive. They're all integers. Relatively prime. They don't all three have a common factor other than 1, but the 1's boring. Okay? Now, x-intercept is where y equals 0, right? If y equals 0, that means this is gone. X equals 6. All right? The y-intercept is where x equals 0. X equals 0, we're left with -6y equals 30, which means y equals -5. Okay? Yes?
What if A or B isn't a factor of C?
Then you get fractions.
Yeah, but I thought we couldn't have fractions.
You can have fractions.
The actual.
You're talking, oh, hold on.
Just the equation.
Yeah.
Yeah, you can't have a fraction in your A, B, and C can't be fractions. These parameters can't be fractions, but your y-intercept or x-intercept could certainly be fractions. Yeah, Jack?
Could be a decimal.
What?
The X or Y or Z.
These?
A decimal can be a fraction.
Yeah, those could be decimals. Yeah. The x-intercept could be 5.5, or what would that be? 5.5 is 11/2, right? So either way, the x and y-intercepts can definitely be fractions. A, B, and C have to be integers.
End up with fractions, decimals, whatever.
Yes.
You can't start out with them.
That's right.
Okay.
In standard form, you can't. Now, slope-intercept form will have fractions in it all the time. But standard form, no fractions, no decimals. A, B, and C relatively prime, and A has to be positive. That way, everybody everywhere gets the same answer. All right. Okay. All right, so if we graph using these 2 points, 6, 0 is here. 0, -5 is here. Doesn't let me do points. It wants to do that. So then we connect those points. When you graph a line, guys, get a straight edge for me. Give me a nice straight line so it looks good. Because we might want to use that line to predict something, right? And if it's off, crooked, can't do it. No, because there's no straight edge for parabolas. Yeah, they're not straight. All right, let's have a look at another one. All right, this one says to just find the x and y intercepts of the graph. This is just asking if you know graphically what the definition of an x and y intercept. And you do, right? What's the x intercept?
-4.
So the tricky part of that is going to be to make sure you recognize the scale of the graph.
Yeah,
try to.
My boy Charlie there is going to want to jump on that, say that's -2, and move on to the next problem as quick as he can without looking at the graph.
Charlie.
So it's -4, 0, right? The x-intercept is a point, and so I want the answer given as a point, right? It needs to be an ordered pair, not just a number. X equals -4 is a vertical line. It's not an x-intercept. This is this. So the y-intercept looks like it is 0, 7. It's a point, so give your answer as a point. Okay? Now, y'all ready? Standard form. Okay? I'm not sure why this is back in there. Yes, any linear equation can be rearranged into standard form by following the rules of solving equations. So sometimes you might just be asked to put this equation into standard form. We're used to taking equations that are in standard form and putting them into slope-intercept. It's important to be able to do it backwards also. The reason it's important is because the ACT is going to ask for, at some point, all three forms of the equation of a line. Most ACT tests that I've seen have all three forms on there somewhere. So you're going to be looking at least 3 questions that deal with these forms of linear equations. All right, so it's an important skill to be very familiar with standard form, slope-intercept form, and point-slope form, which you haven't learned yet. Point-slope form is going to be new for you. I think it's Unit 5, but I know it's in Unit 6. All right, so let's have a look at what an equation might look like. So this says, let's read the directions. Write the equation in standard form. That's one thing we want to do. And then graph it using the intercepts. Now, we could graph this by using the y-intercept, and the slope is down 2 and right 3, isn't it? So we'd get another point somewhere right in this area, and then we could graph it. But that's not what these directions say. These directions say first write the equation in standard form, which means it needs to look like Ax plus By equals C.
No, you can't have a fraction.
That's right. So first thing we need to do is add 2/3 x to both sides. 2/3 x plus y equals 5. And that's where your textbook stops, and your textbook is wrong because that's not standard form. Why is it not standard form? It has a fraction in it. To get rid of fractions, multiply by 3.
There's a black Ford Explorer parked in the drive-through lane that needs to be moved. Please move the black Ford Explorer in the drive-through lane.
Whoops, sorry guys.
All right, so when you distribute the 3, we get 2x plus 3y equals 15. This is standard form, okay? A is positive. 2, 3, and 15 are relatively prime to each other. Okay, yeah. 3 and 15 have a common factor, but 2 doesn't have a common factor with. So it's all 3 are relatively prime. Now, then it says to graph it using the intercepts. Now, let's do this quickly because we're running out of time. The x-intercept is where y equals 0. So if we zero out the y, 15 over 2, 7.5, right? There's your decimal. It's okay to have a fraction or decimal there. The y-intercept is where x equals 0. X equals 0, y is 5. Right? So 0, 5 is here. 7.5 somewhere over here. Okay, there's my x-intercepts, my y-intercepts, and the graph will look like, got a little off, but that's close enough. Okay? All right? Y'all okay with that? Now, so there's 2 skills being tested here. Putting it into standard form is one skill. All right? Graphing it using the intercepts is the second skill. So last example of the day. Okay? First, directions. Write it in standard form. So let's do that first. That means AX plus BY equals C. So subtract 12X from both sides. That gives us negative 12X plus 4Y equals negative 12.
Divide by 1.
You can't have that because it's negative.
All right, so we got two problems, right? A is negative, and they all are divisible by 4. How can we fix both problems?
Divide by 4. Negative
No, you
4.
have to distribute the negative.
That?
Just
divide by
Yeah, or we could just divide everything by negative 4 and kill two birds with one stone, right? You could divide by 4 and then change all the signs.
3x plus
That's good.
y negative
So
y
it's
minus
3x minus y equals positive 3.
3.
Is that standard form?
Yes.
Yes. All right, so there's the first part of the answer. The x-intercept is where y is 0.
And then so it's 1.
It's 1. Yes. It's 1. It's 1. All right.
Okay, that's enough.
The y-intercept is where x is 0,
Negative 3.
negative 3.
I'm getting the heck of it.
Yeah. Now, here's the deal, guys. This is a new skill. There's 1, 0.
Negative 0.
0, negative 3 is right there. This is a new skill, which means it's going to be important not to wait. If you wait until Sunday night to do this homework, you're going to have to remind yourself of all three of these parameters. Do this sooner rather than later. It's easier on you. Okay? Your homework is...
Oh, I forgot to write it down.
This is not online, so you need to write this down. As a matter of fact, the syllabus never made it up this week. Missing on Monday, being out all day Monday was just...
Yes.
It proved a little bit difficult for me to kind of catch up. But
Okay.
next week's syllabus is already done, so you guys will have it from the start. There is your homework. You guys are great. Thanks.